Hello, welcome to section 12.4. I know it seems like we skipped a little bit, namely chapter number 11, but we'll get to it. Or did we do it? I think we skipped it. We'll have to come back to it. We've already done 9 and we are in the process of doing 10. 10 gets split up into different chapters. So, we're going to start chapter 12. And this is section 12.4, which means we're really skipping sections 12.1, 12.2, and 12.3. Because sections 12.1, 12.2, and 12.3 are written such that they don't expect you to have a calculator, and I already expect you to have a calculator. Not only that, I expect you to be able to use it. So I'm just assuming that you're going to use your calculator to take care of some of the stuff that 12.1, 12.2, and 12.3 were about. And it'll give you better answers. There's no need for people to do things like that by hand anymore, ever again. Now, you and I, have already gone over this before in the past. I had to explain to you what an index was. That's the number on the outside. That a radical is the symbol and the radicand is the number on the bottom. And the index is important because it tells you how many it takes for them to get out of jail. You remember all this, I'm sure of it. But in case you don't, whenever you get a problem like this, you're supposed to break this down into its prime factors. So when I go to break this down into its prime factors, 72 is really 8 times 9, which is really 2 times 4 times 3 times 3, which ends up giving us 2 times 2 times 2 times 3 times 3. And all of this is still underneath the radical like it was before. And we talked before about how if it is a 2 here, then that means it takes 2 for it to get out. But if there is nothing written there, then it's an understood 2. Sometimes this index will be a different number. Like if it were a 3, then they would always write a 3 there if they meant for it to be a 3. The only time that we have an understood 2 in mathematics is right there. If there's nothing written, then it's understood to be a 2. So that means it's going to take 2 for us to get out. Well, these are the ones that are in jail. And if it takes 2 to get out, that means that these 2 can get out. And then these 2 can get out. When these 2 come out, it comes out as just 1. And when these 2 come out, it comes out as just one of those as well. Which leaves on the inside a 2. And 2 times 3 on the outside is 6 square roots of 2. And that's how you do it. One of the important pieces of information that you have not had yet is that you cannot have a negative underneath the radical sign, because that is not a real number. So if they ever show you a negative underneath the radical sign, not a minus sign, that's something different, but if they ever show you a negative underneath the radical sign, that means that it is not a real number. And that's what you would write, not a real number. Right here, if we were going to break it down into its prime factors, we don't know what x is, we don't know what y is, but we do know there are 2 x's and there are 3 y's. And our index tells us that it only takes 2 to get out. It only takes 2 to get out. And that leaves us with 1 y left on the inside. So our answer is xy square roots of y. But when we're looking at this one right here, I don't know about you, but I don't particularly fancy writing this down 7 times, and more importantly, I don't want to write that down 15 times. There should be a faster way of doing this, and there is. We said the index here is 2, right? So if you look, every group of 2 comes out as a 1. If every group of 2 comes out as a 1, then I should be able to divide this by 2. So 2 goes into 2 one time, so there's 1 outside, with none left over inside. 2 goes into 3 one time, so there's 1 outside, with 1 left over inside. You can use the same thing over here. 2 goes into 7 3 times, so that's x to the 3rd with 1 left over inside. And 2 goes into 15 7 times, so that's y to the 7th with 1 left over inside. And we didn't have to write everything out, that whole long thing. It's always whatever the index is divided into the exponents. Tells you how many you're going to have outside and how many are left inside. Okay, let's try some. Ooh, let's make it challenging. For the first one, that one. For the second one, for the third one, and for the fifth one, that one. Go ahead and pause. Try those 4. Let's see how you do. Okay, let's see what you did. For this one, remember I told you couldn't have a negative underneath? That's a negative underneath, which means our answer should just be not a real number. There is an answer, but all you need to know right now is that that answer is not a real number. Over here, since it is an index of 2, square root, when I go to write it out, that's 12 times 10. So 2 times 2 times 3 times 2 times 5 m to the 6, because I got my trick for the 6's. Takes 2 to get out. So there's my 2 to get out. None of these can come out, but m to the 6, 2 goes into 6 3 times. Which leaves all this stuff inside. Go ahead and multiply it all back together. 3 times 2 is 6 times 5 is 30. Over here, 88. 88 is 8 times 11, so that's 2 times 2 times 2 times 11 times 8 to the 4th. Takes 2 on the inside to make 1 on the outside. So that's a 2. None of this can come out. 8 to the 4th, 2 goes into 4 2 times, which leaves me with a 2 and an 11 inside. So that's 22. For this one, it was meant to be hard. Don't worry. If you take it bit by bit by bit, and you start at the most center bit, which is how you do order of operations, which is what this is, then I would take the the square root of 625. And because I've memorized it, I know that the square root of 625 is really 25. Because 25 times 25 gives me 625. Now, how are you supposed to know that if you didn't memorize it? Well, I would expect you to have gone through and said a number that goes into that evenly is going to be 5, and figured out that it was 5 times 125. 5 will go into that, which will make it 5 times 5 times 25, and 25 is really 5 times 5. And those two will come out, and those two will come out, leave me with 5 times 5, which is 25. But there's still this bigger square root on the 25. So what's the square root of 25? It's just 5. Sorry, when you take it, it's 5. Once you take a square root, the radical sign goes away. We don't keep the square root on it if there's nothing underneath it. So the square root of 25 is 5. Okay. So you just take the square root of the inside thing, and then you take the square root of that again. Two-step process, that's all. Alrighty. Which brings us, very quickly I might add, to classwork and homework. And since it was so quickly, I don't mind giving you a whole bunch of each. So for classwork, you have numbers 9, 17, 29, 37, 45, and 49. And then for homework, you have numbers 23, 27, 31, 33, and 35. And that takes care of section 12.4, which means tomorrow you'll do section 12.5. Okay, see you then.